Hello, my name is Keshwani. That's K-E-S-H-W-A-N-I, Keshwani. We are here because we want to prepare for GRE. We have been solving GRE math problems out of this book here, the official guide to the revised GRE, the second edition. If you do not own this book already, purchase one immediately. You're going to need it. The problems that we are about to solve are the ones that you will find on page number 244. Please turn to it. Page number 244, and today is our lesson number 348. These problems that you see there on page number 244 are the exact same problems that appeared in the first edition of the revised GRE. We have already solved every single problem from this book. If you're interested in watching the original solution, you will find the original solutions to these problems on day number 139. Right now, today, we're going to redo this problem at a faster speed. We're not going to go into too much of the details. If you find that you are lost on certain concept, and if you feel that I did not explain something, I assure you that I did explain it in the original version, which I said it goes at a slower pace. It goes into far more details than I will here. Okay? So here we will not explain anything. We're just going to do the problems. First problem number 5 is what we're going to do. It just says simplify. Our job is to simplify the expressions here. The first one is n raised to 5 times n raised to 3. Now since they have the same basis, they have the same base of n, we just add the exponents. So it is simply n raised to 5 minus 3, which is n squared. B. It says s raised to 7 times t raised to 7. Now here the bases are not the same. So we cannot do anything with them. The most that we can do here, instead of writing them separately, s raised to 7 and t raised to 7, the most we can do is put s and t together and raise that quantity to 7. That's about it. Let's do C. C says r raised to 12 over r raised to 4. And we know that if we have a raised to m times, let's do C over here. We know that if we have a raised to m times a raised to n, it is simply a raised to m plus n. But if they're being divided, a raised to m divided by a raised to n is simply a raised to m minus n. I just said a little while ago I wasn't going to explain anything, but there we go again. So that's what it is. We're dividing here to be able to subtract the exponents. So C is r raised to 12 over r raised to 4, which is same as r raised to 12 minus 4, which is r raised to 8. Let's look at D. D says 2a over b raised to 5. 2a over b raised to 5. And the only way we can put this in the simplified form is to write this down here, 2 raised to 5 times a raised to 5 over b raised to 5. And how much is 2 raised to 5? 2 2s are 4, 4 2s are 8, 8 2s are 16, and 16 2s are 32. So if you multiply 2 by itself 5 times, you will find that it equals 32. And it is simply 32, not 35. 32, this is the fifth power, I put down 5 independently. 32 times a raised to 5 over b raised to 5. And that's about all we can do here. Let's look at E. E says w raised to 5 raised to 3. In that case, here if we have b raised to m raised to n, it is simply b times b raised to m times n. Here we do not add the powers, we have to multiply the powers. So that's what it is here. So it's going to be w raised to 5 times the negative 3, which is going to give us w raised to negative 15. Let's go on then. F. There's 2f up here. Let's go up here. f says 5 raised to 0 times d raised to 3. And what do we know about a number raised to 0? Any number. It doesn't matter what that number is. Any number raised to 0 equals 1. This is something we have to know. And how would you find the same statement in the math textbook? Of course, in the math textbook, mathematicians don't like to write everything out. They write it in their own language, in their own symbols. So how do we find this thing, same exact statement, using the mathematical symbols? Well, for any number, they will use a variable. And typically for a number, they will say n. N represents any number. It could be any number. Positive, negative, fractions, any number. N represents any number raised to 0 equals 1. This is the same as this. Any number raised to 0 equals 1. So here we have 5 raised to 0, which is 1. So it's just 1 times d raised to 3, which is simply d raised to 3. Nothing to it. So that was f. Oh, it goes on. There is g and h. Let's look at g. We need the room. We need the room big time. In G we have x raised to 10 times y raised to negative 1 over x raised to 5 times y raised to 5. And we have to do the same thing that we did before. So x raised to 10 divided by x raised to 5 is same as x raised to 10 minus a negative 5. It's the same as x raised to 10 minus, you see, m over n is simply m minus n. So here it is negative 5, so it is 10 minus a negative 5. And here we will have y raised to 5, and then we have to bring this negative down here. When we bring this negative one down, it becomes positive. Essentially what it is again is negative and a negative 1. These are the sort of things that I'm talking about here. If you're lost here, I'm reminding you one more time, watch the original solution, day 139, you will get more out of it. This is only for those people who do not need a lot of help. So it is 10 raised to x raised to 10 minus a negative 5, which is simply 10 raised to 15 over y raised to 5 minus a negative 1, it's going to be 5. That's all. So that was, something has gone wrong here. 5 plus a 1 is not a 5, it's a 6. Let's do the last one, h. H is 3x over y squared divided by 1 over y to the raised to the 5th. See what we can do here. And what do we know about multiplying it by, or rather dividing one fraction by another? If we have 12 over 2 divided by 1 over 3, 12 over 2 is 6. 6 divided by 3 should give us 2. This would be 6, and 6 divided 6. This part is 6. 6 divided by 6 divided by 1/3. It is 6 divided by 1/3. 6 divided by 1/3. And what do we do here? We take our original fraction 6 divided by 2, and we have to multiply it by the reciprocal of the other one, which is exactly what will happen here. It is 6 divided times 3 over 1. This is what we got here, 6. We will get a 6 here. So that's what we have to do here. We'll take the second part here, 3x over y squared times, let's open this up, 3x squared. 3 squared is 9, and we get x squared over y squared times y raised to 5 over 1. We take the reciprocal of this guy. So it becomes y over, essentially what it becomes is y over 1 raised to 5, which is same as y raised to 5. And now we have to combine the two y's together. So we have x raised to 9x squared times y raised to 5 minus 2, which gives us 9x squared raised to y cubed. That's all. Let's go on then. We're going to do the next problem, problem number 6. In problem number 6, we have to solve simple linear equations. The very first one is 5x minus 7, we are told, equals 28. And of course we have to solve for x, which means we want the x by itself. So we have to get the 7 to that side. We add 7 to those both sides. And that brings this 7 over there. 7 cancels out. And 5x equals 28 plus 7, which is 35. We want the x by itself. Divide both sides by 5. So we can get rid of this 5. And x equals 35 over 5, which is 7. Once we have done that, it only takes a few seconds to actually quickly verify it. So let's verify it very quickly. 5 times x, which we are claiming is 7. 5 times 7 minus 7. 35 minus a 7 is in fact equals to 28, which is what we are told here. The 5 times x minus 7 equals 28, which is exactly what we find here. Number 2. Part B. Part B says 12 minus 5x. 12 minus 5x, this is part B, equals x plus 30. Again, we want to bring all the unknown to the left hand side. Why to the left hand side? Because that's just a convention, that's just a tradition. We're just going to obey we're just going to honor the tradition. The tradition dictates that we bring the unknown to the left hand side. So let's bring x to this side by adding x to, by subtracting x from both sides. This is the plus x, so let's subtract x from here. And then bring the 12 to that side by subtracting 12 from both sides. So this x will cancel out with that x. This 12 will go out. 5x, negative 5x and a negative x is going to give us negative 6x equals 12 minus 30 minus 12. 30 minus 10 is 20, so it's going to be 18. Divide both sides by negative 6. And now x equals 18 divided by negative 6, which gives us negative 3. Again, we're going to quickly verify it by putting it in our original equation. Original equation says 12 minus 5x, x is negative 3. We are claiming that x is negative 3, so we have to show that it actually works. Has to equal x plus 30. Negative 3 plus 30. Well, negative 3 plus 30 is 27. Let's see what we get here, shall we? 12 and a negative becomes positive, positive 15. And what do you know? 12 plus 15 does equal 27. Part C. C says, part C, 5 times x plus 2 equals 1 minus 3x. Now before we worry about bringing all the x to one side, we first have to open this parenthesis. So that's 5 times x, which is 5x. 5 times the 2, which is 10, equals 1 minus 3x. Let's bring this 3x to this side by adding 3x to both sides. And let's bring this 10 to the other side by subtracting 10 from both sides. This is a, so this positive 10 and a negative 10 is going to drop out. That was the whole point. This negative 3x and the positive 3x is going to drop out. And we end up here 5x plus 3x, which is 8x, equals positive 1 and a negative 10 is going to give us negative 9, and x equals negative 9, 8. Now this one is going to be a little tricky to verify, but we're going to verify anyway. We're going to verify anyway, but it's going to be a little tricky. So let's do it at the bottom here. So let's verify it here. So 5 times x plus 2, which is our x we're claiming is 998. X plus 2 has to equal 1 minus 3 times x, which is 98. Now watch what happens. Okay, watch what happens. This 2, how can we write this 2 so that we have the denominator of 8? How many 8s make 2? 8 8s make 1. 8 over 8 is 1, which is exactly 8 over 8 equals 1. So this can be written as 16 over 8. Now watch what happens. So we have 5 times. So now we have negative 9 and a positive 16. Negative 9 and a positive 16. 16 minus 9 is going to give us 7. So 5 times 7, 8 has to equal this amount. 1 minus, and again, 1 minus 3, 8. Negative 3 and a negative 3 is going to give us positive 27, 8. And this can be written as 8 over 8. Oh, there you go, we're almost done. That's it. This one right here, we wrote it as 8 over 8, and this is negative 3 times a negative 9. A negative 3 times a negative 9 is positive 27. And this was 1, which we wrote as 8 over 8. So this is 8 over 8, this is 27 8, we get 35. You get 35 over 8, and here we get 5 times 7, which is 35. So it works. That is the right answer. Let's do the last one. Let's do not the last one, I meant part D. So if the nature of the problem is such that you have to look at the cost and the benefit, obviously. Just like anything else in life, you have to look at the cost and the benefit. If the nature of the problem is such that that you find that you are able to verify your answer within seconds, 5, 10 seconds, maybe 15 at the very most. If you are able to verify your answer, I like to have that peace of mind. I like to buy that insurance, but I'm not going to. It's an insurance, and just like any other insurance, it depends on the premium. Do I want to buy the insurance? Well, it depends on how expensive the premium is. If it's going to cost me more than 10 seconds, I'm not going to bother with it. But if I can verify this thing within 5 to 10 seconds, why not? I'm going to verify it. X plus 6, 2x minus 1, we are told equals 0. Part D says x plus 6 times 2x minus 1 equals 0. So we have two quantities. Let's call this quantity A and let's call this quantity B, and we are told that A times B equals 0. A times B equals 0. What does it mean? It means either the product of two quantities, the only way the product of two quantities can be 0 is either A is equal to 0 or B is equal to 0. That's the only way that is possible. So that's what it is. Here, either x plus 6 is equal to 0 or 2x minus 1 is equal to 0. If x plus 6 is equal to 0, that implies that x is equal to negative 6. And if this is true, this implies that 2x must equal 1, which in turn implies x must be half. Let's verify both of these answers by putting them in here. It will only take a few seconds. Negative 6 is very easy. When you put a negative 6 in here, a negative 6 and a positive 6 is going to give us 0, and 0 times anything is 0. It doesn't matter what this thing is. Once this comes out to be 0, 0 times anything is 0. It works. Similarly, when we put a half in this thing, we get 2 times x minus a 1. 2 cancel out, and 1 minus 1 is 0. So if 1 minus 1 is 0, then if this quantity is 0, it doesn't matter what this quantity is, 0 times anything is 0, it works. And that was part D. Let's see what we have in part E. Now once we get to part E and F, listen very carefully, part E and F are no longer linear equations. They have second powers in it. They are quadratic equations. Part E and F are quadratic equations, which means either you will have to use factorization, a method called factorization, or if we cannot factorize them, if we cannot find the factors, we may even have to resort to using quadratic formula. But they are not linear equations. So I'm going to stop right now because those are different animals. We'll do them tomorrow. Okay? Bye now.